So now we're going to practice partial derivatives. I don't know. I'll try to do as many as I can. So we'll do just a couple, maybe let's do 10. Just practice 10 of them. So first one, f of x comma y equals x squared plus y squared plus 3. So let's start off with a simple one. So fx and fy, okay? So let's just start with the simples. So if I take the derivative with respect to x, remember, if it doesn't have an x variable, it's like a pure number to me. So this is going to be equal to 2x because the derivative of x squared is 2x. And then y squared does not have an x, so it's 0. And then 3 is 0. So then I get 2x. Okay. Same thing with y. X squared doesn't have y on it, so I get 0. This becomes 2y, and I get 0, and it's 2y. Okay. If I wanted fxx and fyy, well, I just take the derivative normally. So this would be 2, and then this would be 2. Okay. Now, if I wanted fxy, I go back to this one right here, and I take the derivative with respect to y. So 2x just becomes 0. If I wanted fyx, I go to this one, and I take the derivative, and I get 0. And these right here should be the same. Okay. Are there any questions so far? So let's pick up the difficulty and let's do, f of x comma y equals x squared y plus 3y plus x squared y cubed minus 4x. Okay. So all I've done is put in more variables. So we just got to be very aware of what derivatives we're taking. So we always start off with fx and fy. Okay. Remember, if I'm doing fx, the y variable is like a number to me. Just pretend it's like 7. Okay. In your mind, you think it's the number 7. So the derivative of x squared with respect to x is going to be the following. You're going to bring down the 2, and you're not going to, the y is a number to you. You just leave it alone. It doesn't disappear. It's right there. Just leave it alone. Now, the derivative of 3y with respect to x is 0 because it doesn't have the letter x on it. So it's just like a number. The derivative of x squared y cubed is going to be 2x y cubed, just like that. Okay. Again, y cubed is a number to me. I just leave it alone. And then the derivative of 4x is just a minus 4. Okay. So this is equal to 2xy plus 2xy cubed minus 4. Okay. Then you repeat the same thing for the y variable. So the derivative of x squared y is just x squared. The y becomes 1, just disappears. The derivative of 3y just becomes a positive 3. The derivative of x squared y cubed is going to be, you bring down the 3, you do not touch the x squared, it's just a number, and then you have y squared. And then the minus 4x is just a plus 0 or minus 0, doesn't matter. And then I get x squared plus 3 plus 3x squared y squared. Are there any questions on this example in particular? All right. Then I'm going to do fxx and fyy. So I repeat the same thing. Hopefully I have enough room. So the first one, I just make the x a number 1 and I leave everything else alone and it becomes 2y. Same thing with the second one, 2xy cubed just becomes 2y cubed. The x became a 1 and so on and so on. Okay. And then 4 just becomes a 0. Just so you know, minus 0 and plus 0, they result in the same thing. Now for fyy, the x squared becomes 0, the 3 becomes 0, and then I bring down the 2, and I get 6x squared y. Notice the x squared is not being touched because it's a number to me. Oops, sorry. And so my final answer is 6x squared y. Okay. And then if I wanted to do fxy, I would go to this one right here. Let me just box these so you know what the solution is. So I go to fxy, and the y, this one right here, is going to become a 1, and I get 2x. The y cubed is going to be, bring down the 3, I get 6xy squared, and the minus 4 becomes a 0. So plus 0. And I get 2x plus 6xy squared. And then if I do it the other way around, the derivative of x squared, because I'm using this one right here, is going to be 2x. The derivative of 3 is 0. And then the derivative of x squared is going to be 6x y squared. And I get 2x plus 6x y squared. Notice they are the same. Okay. Any questions on that one? Just want to make sure. So we'll do another one. But hopefully over the next few days, you're just practicing these. And I say that just because in order to do a lot of the problems like critical points, max min, you have to know how to do these correctly. Okay, but are there any questions at home? I'm going to do one from the homework that's the exponential one, so you can see how to do that. All right. So number 3, f of x comma y comma z is equal to x e to the 2y plus 3z. Okay. So f of x, okay, so fx, the derivative with respect to x. Notice this part right here, there is no x term. So it is just a number to me. So the derivative is just 1 times e to the 2y plus 3z, which is just e to the 2y plus 3z. I think that one is difficult to students because the answer is just too simple. Like the answer is just too easy, right? For some reason, our brains are like, I want to struggle for my answer to feel satisfied, but if it's that easy, I feel like I did something wrong, right? You know, sometimes you're told that as math students that if the answer was too easy, it's probably wrong, but sometimes it really is that easy, especially with partial derivatives. Okay, when it comes to partial derivatives, a lot of the times it is easier than you think. So just keep that in mind. Fy. So now we have to go into the exponent. So just to remind you, the derivative of an exponential with a function in its exponent is the original function times the derivative of the exponent. Okay. So to me, x is a number, no product rule. So I'm going to do x e. I just write down the original one. I don't do anything to it. I just write it down. Then I'm going to multiply it by the derivative of the exponent. So because I'm doing y, right, this is y, it's going to be 2, because 2y is 2, and then plus 0, because 3z would be 0. And so I get x e to the 2y plus 3z, and then I'm going to put a 2 in front. And that's my answer. Any questions on that? And then we do the same thing for z. This one has 3 variables, so you're going to do it 3 times. And so x, not z, so I just leave it alone, e to the 2y plus 3z But now the exponent, instead of it being 2 plus 0, it's going to be 0 plus 3. So then it's 3x e to the 2y plus 3z. Okay. Are there any questions on that example? Give you guys a second to look over that. Now, if there was an x in the numerator, sorry, an x in front and the x in the exponent, that would be a case of product rule. But most of the time you don't have to use product rule or anything like that. Can it happen? Yes, but usually you don't have to, okay? Any questions? So I think that's a good amount of examples for now. You know, if I wanted to do fxx, so let's just do fxx real quick. There is no x term, so it's just 0, okay? If I wanted to do fyy, it would be 2x e to the 2y plus 3z times 2 again. So it's just another 2. If I wanted to do fzz, it would be equal to 3x, sorry, e to the 2y plus 3z times 3. And it honestly just keeps repeating like that over and over again. Okay. Any questions? So we'll practice more of this on Tuesday when we have our second review session that covers chapter 15, but I think this is a good little video to just kind of look over. If you can do these ones, you're on track, okay? So just make sure you're able to do these. Hopefully you saw the announcement about the homework. There is a way to extend homework if you don't finish it, as long as you haven't looked at the answer key. So read over that announcement. So if there's any old homeworks that you didn't finish, with the exception of 4.1, because that one's past the 2-week deadline. So you'll have to manually ask me so that I can open it for you. But other than that, I think this is a good stopping point, and I'll answer any last questions before we head out.